Hey, Dr. Ray here, founder of the Learning Liaisons, and welcome. Welcome to our Wednesday evening math sessions featuring our math specialist and your math specialist, Amy Sink. In the next hour, Amy has put together a sample set of approximately 10 practice questions that run the gamut from kindergarten levels all the way through 12th grade high school math. Now, I know you are attending here, watching this, and you're like, well, I'm doing elementary in Texas, or I'm doing elementary in Praxis, or I'm doing high school math in Florida, or middle school math in Texas. And what's going on here, right? So we're doing these sessions to help you guys out and provide you with different ways to look at problems and to build that confidence. Because here at the Learning Liaisons, one of our major objectives is to clear up the testing confusion, give you the support you deserve in order to nail your exam and be done with it. So our focus is on math. Now, are we going to be just focusing on high school math the whole hour or elementary? No. We've got a mixture here. Now, Amy's going to go through a bunch of problems. You're going to have the opportunity to download those as a PDF. So when Amy starts, just pay attention to the screen. We're going to have a message there for you so you can download the PDF in case we don't get to all the problems or want to practice on your own. She's going to do her best to go across all different grade levels. If you have a question, you feel free to ask Amy your question as well. We're teachers here too, so we can multitask. Our job is to make sure that we give you what you need to be successful. But if you're like, dang it, I didn't have any questions this week, don't worry. We'll be here next Wednesday night as well. So bring those questions with you if you want, and you can ask Amy away. Because here at the Learning Liaisons, we pride ourselves in providing you guys the support you need to pass your exam. So whether you're our Florida teachers here with our FTCE exams, our national exam, Praxis peeps, big shout out to you guys out there too, and especially our newcomers to the Learning Liaisons brand, TExES Prep. So whether you're elementary, middle school, and high school, we've got your back. So sit back, relax, grab your popcorn, get ready to learn some math, and stay tuned for the end because I'm going to jump back on to close this out, and I got a special surprise for you guys who really want to get the real deal prep and get everything you need to be successful and practice, clear up that confusion, and pass your certification exam on the next attempt. So, welcome to the Learning Liaisons community. Always remember, it's when you pass, not if you pass. So without further ado, let's turn it over to the reason why you're here, Amy. You with us, Amy? Let's get going.
Hello, everybody, and welcome to Wednesday Night Math Night, July 4th edition. I am Amy Sink, and I am one of the math specialists here at the Learning Liaisons, and we just absolutely love what we get to do here, which is help you be more competent and confident in your math ability when you're walking into this exam. And so we just absolutely love this opportunity to be able to sit together with you and work through some math problems. Like Dr. A said, it is pre-K through 12th grade, so it's not going to be everything exactly related to your test, but it's just a sampling of what we have to offer. If you have questions that you want me to go over in the upcoming weeks, please let me know in the next week section. So please let me know in the comments so that I can add it to the next week section. Each week, I love the opportunity that I get to cater some of these problems to what you need. And so let me know in the comment box what you need from me. If there's a specific problem or a specific topic that you're looking for, you can absolutely let me know in the comment box, and I'm happy to build some problems around that in the upcoming weeks. I can't guarantee that it'll be next week just because of how I flow things, but I can definitely guarantee that I will go over that topic in the next couple weeks. I am from Central Florida, and I have been here for a really long time. I've been in education for 14 years, and I am currently an assistant principal in a middle school and a high school, but I spent many years in elementary school before that. So welcome to Wednesday Night Math Night. Welcome to the Learning Liaisons community. Let me know in the comment box. I always like to do a little get to know you. It just makes it feel a little bit less like a computer screen and a little bit more like we're just hanging out doing math. So let me know in the comment box where you're from, what test are you prepping for, and what are your family's plans for the July 4th holiday? Where are you from? What test are you prepping for? And what are your family's plans for the July 4th holiday? Some people go all out. Some people just lay low and hang out at home. We are not sure what we're going to do. The weather is supposed to be pretty bad here in Central Florida. I guess there's some tropical depression, and so some of our community events may not actually happen because of that. They're looking at being postponed. So we're just kind of waiting to see what July 4th is going to bring. So we're not sure what the week is going to bring us. So yeah, maybe just hang out with some friends, do some sparklers, all that to say, where are you from? What test are you prepping for? And what are you planning on doing for the July 4th holiday with your family? And without further ado, let's go ahead and dive right in. It's going to be a little bit of a shorter session tonight. It's not going to be a full hour. So I just wanted to prep you for that. And like I said, if you have any questions or things that you want me to go over, let me know in the next week section. All right, let's go on into problem 1. As I'm working through problems, if you have any questions at all, you can always let me know in the comment box. I am happy to answer any questions that you might have. A specialty soap company sells vanilla soap for $3.95 per ounce and lavender soap for $5.95 per ounce. How many ounces of lavender soap should be mixed with 3 ounces of vanilla soap in order to create a mixture that sells for $4.75 per ounce? How many ounces of lavender soap should be mixed with 3 ounces of vanilla soap in order to create a mixture that sells for $4.75 per ounce? So the interesting thing about this problem is it was written to be solved using a system of equations. It was written to be solved using a system of equations. However, which is like 2 different equations, and then you add or subtract them, and you get you get an answer. However, I find this kind of problem, especially when it's multiple choice, to be easier to use the multiple choice answers as a guess and check. So if my vanilla soap sells for $3.95 per ounce, and my lavender soap sells for $5.95 per ounce, and then they tell us they're looking for how many ounces of lavender soap. So this is ounces of lavender soap. That's what you're solving for, right? Should be mixed with 3 ounces of vanilla soap. So no matter what, we're using 3 ounces of vanilla soap to create a mixture that sells for $4.75 per ounce. So let me figure out how much my vanilla soap is going to cost. $3.95 times 3 ounces, because this is per ounce. I'm pulling up my calculator. Equals 1185. Now watch this problem solving method I'm about to do. I'm adding that to my lavender soap, right? And how much it's going to cost. And that's going to give me a total cost of blank ounces. But then if I divide my total cost of my ounces by the number of ounces, then I can get my per ounce cost. Are you following me? So let's pretend we only buy 1 ounce of lavender soap. So $5.95 times 1 equals $5.95, right? So if I add $5.95 to $11.85, watch what happens. That equals $17.80 total. For how many ounces? 3 plus 1 is 4. If I divide my total cost by 4 ounces, because that's how many ounces are in my bucket right now, I'll get the per ounce cost. $17.80 divided by 4 is $4.45. Does that equal $4.75 per ounce? No. Now I'm going to do the same process with 2. I don't need to do my vanilla again because my vanilla remains the same at $11.85. I'm always going to be purchasing 3 ounces of vanilla plus 2 ounces times $5.95 is $11.90. And that total cost when I add $11.90 and $11.85 equals $23.75. Now what? Divide that by how many ounces. This time it's 5 ounces, 3 ounces of vanilla and 2 ounces of lavender. And that equals $4.75 per ounce. Now, we could have used a system of equations and that just would have taken us a little bit longer because we would have had to figure out how to set it up, right? And I'm just a woman of like, let's get to the answer because it doesn't matter how you get to the answer, right? It doesn't matter. They're not looking for how unless the question literally says, what series of steps should we take? Which they do sometimes. But for a problem like this, we don't need to stress about that. Use your answer choices to help you and move on. That is one of my favorite strategies to use. All right, let's go on to number 2. A circle is drawn on a coordinate plane. The circle has a diameter that intersects the circle at points A and B, which are at 8, -2 and -4, -6, respectively. Which of the following represents the equation of this circle? Which of the following represents the equation of this circle? All right, this is a fun problem. So I love circles. A circle is drawn on a coordinate plane. So I'm going to draw my coordinate plane. Here's my circle. I love that feature of my little program that can like literally draw me a perfect circle. And it has diameters which are at 8, -2. So 1, 2, 3, 4, 5, 6, 7, 8, 1, 2. And -4, -6. 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. So there's the diameter. And there's approximately where my circle is, right? I tried to put a circle with a diameter there. Now, you're probably not going to be able to draw this super duper well unless you have a literal grid paper. And even then, it may not be completely accurate. However, if you can get a semblance of this image drawn, you can start to eliminate some of these answer choices, right? So I know that my center is going to be somewhere around here-ish, and that my radius is going to be that length about, right? Which means that my radius is going to be about 1, 2, 3, 4, 5, 6-ish, possibly 6-ish for a radius. And my center is going to be like 1 or 2 over and down a little bit. So what do we know about our equation of a circle? Equation of a circle. And I'm reconnecting my iPad right now, so just give me a second. It just disconnects sometimes, and that's okay. Equation of a circle. We know that the equation of a circle is, sorry, give me a second. We know that the equation of a circle is x minus h squared plus y minus k squared equals r squared, where hk is my center, right? x minus h squared plus y minus k squared equals r squared. So the fact that we have a minus h and a minus k in our original means that the actual point is going to be opposite of that. And so let's take a look at these answer choices to kind of understand what we're dealing with here. So that means that my center for this equation, is going to be 8, -2, because I'm going opposite of what these signs say. My center for this one is going to be 2, -4, -4, -6, and 2, -4. So if I plot these points, and let's pretend I have no idea how to solve this problem. The real way to solve this problem would be to use the midpoint formula to find the center. And then you can do process of elimination. But I want to show you how you could do this. If you can get a halfway decent circle drawn on your grid paper, which I'm pretty sure most of the testing centers give some sort of grid mat, or if you can do it the way I did it, where I didn't have grid paper, but I was able to at least get an idea of what quadrant this should be in. Now I can look 8, -2, 1, 2, 3, 4, 5, 6, 7, 8, -2. Well, if this is a point on my circle, then it can't be my center. This is literally a point that they gave me on my circle. That can't be the center. A is out. C is also out. This is the other point on the circle. It cannot be the center. So I've already eliminated 2 answer choices, and I haven't even done a midpoint formula and I didn't even need to have a good picture to realize that these points matched. I didn't even have to draw a picture to know that those couldn't be my centers. Now, 2, -4, that kind of makes sense. Over 2, -4, that kind of makes sense to be my center. Now, is my radius going to be 40 or 160? Now, if I was a good guessing one, I would guess that that B would be the correct answer. If I was in a crunch, I didn't have time, I would guess that it would be B, because the square root of 40 is between 6 and 7. Between 6 and 7, because 6 squared is 36 and 7 squared is 49, and this is in between it. And the square root of 160 is between 12 and 13, because 12 squared is 144, 13 squared is 169. And looking at this, if I know that my center is at 2, -4, and I have a point at 8, -2, then I can create a vertical line here to estimate what that radius is going to be. And that is going to be closer to 6, 7 than it is between 12 and 13. Now, how would I actually find this? How would I actually solve this? I would use the distance formula if I wanted an exact answer. So the midpoint formula for these two would give you your center, and the distance formula will give you your radius. So I can do the distance formula between my center and one of these points. So distance equals the square root of x minus x squared plus y minus y squared. So the square root, and I'm going to choose 2, -4. And I'm going to choose -4, -6 as my other point. I'm reconnecting right now. All right, I'm choosing 2, -4 and -4, -6. So x, remembering that our x's are first and then our y's, x minus x squared plus, because I did this x first, I have to do this y first. Y minus y squared. You notice that I pulled that -4 with it. This becomes a positive. So the square root of -4 minus 2 is -6 squared plus -2 squared. So that all equals the square root of 36 plus 4, which is the square root of 40. So this is your radius. And then your radius squared is the square root of 40 times the square root of 40, which equals 40. When you do a square root times a square root, it equals whatever's on the inside. So that's why this is 40. So B is the correct answer algebraically, but I wanted to show you you could actually solve this without using any of that algebra. All right, let's go on into problem number 3. A function table is shown below. What is the rule that is demonstrated in the table? What is the rule that is demonstrated in the table? All right, so a function table is shown below. What is the rule that is demonstrated in the table? So I see that I have an input and an output. A rule demonstrated by a table is going to do, you're going to do something to the input to get an output, right? So if I'm looking at each of these rules separately, I can apply each of these rules to one of these inputs and see if it equals the output. I never do it to the first one. Why? Because sometimes they'll make multiple rules work for the first point, because like, think about it. Like if I have a graph that looks like this, and let's say this is my first point. These input output tables are not always lines. Keep that in mind. But let's say this is my first dot. Sometimes we have other lines and graphs that can go through. There's an infinite number of lines that can go through that point that follow different rules, right? And so they might make A one of these lines, and then B will actually be the one that works. And so you want to be cautious of that. And I've found that to be true just in my years of experience. So I'll often pick like point number 2 or 3, and then I'll test it against another one. So let's pick this one right here. I'm going to apply each of the rules until I get my output. So add 4. Is 15 plus 4 equal to 31? No. So that is not the correct rule. Add 2. Is 15 plus 2 equal to 31? No. So that's not my rule. Multiply by 2 and add 1. Is 15 times 2 and add 1 equal to 31? 15 times 2 is 30 plus 1 equals 31. That works. I'm going to stop there. I'm now going to use that rule on another point to make sure it works. 14 times 2. Is 14 times 2 plus 1 equal to 29? 14 times 2 is 28 plus 1 is 29. We have found our answer. So once you find your answer, you want to make sure that you cross-check it against another point to make sure that it works for the entire table. Questions? All right, moving on to problem number 4. Rolling on right along. A function table is shown below. What is the rule that is demonstrated in this table? So the difference between this problem and the problem before was that our rules here were words. which they are sometimes easier to interpret, right? But our rules here are equations. And that can sometimes be a little bit harder to interpret, but I'm going to give you a pretty quick way to figure this out, okay? So your inputs are your x's, and your outputs are your y's. Your inputs are your x's, and your outputs are your y's. So I can plug in any of these inputs into an x value. And if the y value after solving is an output, then we have found our answer. So again, I am going to choose my third point. This is going to be my tester point. So y equals 3 times, plug in this input, 2 plus 3. 3 times 2 is 6 plus 3 equals 9. Does that equal 9? Yes, it does. And I did not do that intentionally. So, all right, let's test another point. Let's test -2, -3. Y equals 3 times -2 plus 3. -6, because 3 times -2 is -6, plus 3 is -3. That works as well. So A is our answer. Let me show you one that doesn't work so that you understand. So we're gonna still plug in our third point, but I want to show you what doesn't work. Let's plug it into D. Y equals -3 times 2 plus 3. -3 times 2 is -6 plus 3. -6 plus 3 is -3. Does that equal 9? Because remember, my output is 9. No, it does not. That's what it would look like if you were to do the input output and not get the correct answer for letter A, right? Although, listen, no one's complaining when we're using a guess and check method and A is the correct answer. No one's complaining. All right, problem number 5. A quadratic equation is given below. How many and what kinds of roots does the quadratic equation have? How many and what kinds of roots does the quadratic equation have? All right, so when we are looking for how many and what kinds of roots, we are looking for the discriminant. Now, this should sound very familiar for my high school people. This is definitely a 6 through 12, 7 through 12 kind of problem. And this should look very familiar for my people who are taking the high school course. Your discriminant is that middle part of your quadratic equation, which is -b plus or minus the square root of b squared minus 4ac all over 2a, right? This piece is your discriminant. And that right there is going to tell you how many and what kind of roots. Why? Because if that number is a specific number, it's going to inform how the rest of this solves, right? If my square root is 0, then I'm not plussing or minusing anything because +0 and -0 equal the same thing. So if my discriminant equals 0, then I have one real rational root. Because rational means that it can be like a fraction. It's a rational root. Irrational is like the square root of 12. Like you can't take the square root of 12. You end up with an infinite non-repeating decimal. So if the discriminant is 0, you end up with one real rational root because you're adding 0 and subtracting 0, which is the same thing. If your discriminant equals a negative number, you end up with imaginary roots because you cannot take the square root of a negative number. Nothing times itself equals a negative number. If the discriminant equals a positive perfect square, then you have two real rational roots. Because if it's like the square root of 9, the square root of 9 is 3. Something plus 3 divided by something. That's a clean, rational answer. But if the discriminant is a positive, not perfect square, the square root of 12, right? A positive, non-square, perfect square. Then you end up with two real. They're real. That's a real number. It's not imaginary, but it's going to be irrational because you're going to end up with a never-ending decimal, okay? So once we know all of that, and this is all stuff that really, once you think about it, it just makes sense. Then you don't have to use the entire quadratic formula on this. You can just use the discriminant. That's all you need. So b squared minus 4ac. That's all I need. This is a, this is b, this is c, because they have the exponents going in descending order. So 3 squared minus 4 times a times c. 3 squared is 9. 4 times 3 times 17 is 204. But it's a negative because you have one negative and two positives. 9 minus 204 equals negative 195, which is going to give me two imaginary roots because I cannot remember, this is the piece that is under the square root. Can I take the square root of a negative number? I cannot take the square root of a negative number. So it's two imaginary roots. We end up with two imaginary roots. Let's do one more like this, and then we'll close up for the night. So I'm going to actually copy and paste this whole thing so that we remember what our rules are. Okay, so there's our rules. And let's copy this part over as well. Okay, so I'm going to do my discriminant, A, B, C. B squared, so 3 squared minus 4 times A times C. 3 squared is 9. 4 times 3 times 17. 204. But I have a negative times a negative, which creates a positive 204. 9 plus 204 equals 213. And I know that I can't take the square root of 213. If you didn't know that, you could sit and you should know that 12 times 12 equals 144. And then you could kind of go from there. 13 times 13, I know, is 169. And then 14, we're getting close. So it's not going to take long. 14 times 14 is 196. And 15 times 15 is 225 if you didn't have like a calculator that had a square root. And so this is not going to give me a perfect square. So all that means is it's a positive perfect square. So we're looking at this one, which means, no, it's not it's a positive non-perfect square, which means I'm going to have two real irrational roots, two irrational real roots, because I can't take the square root of that number, but it's also not imaginary. Like it'll give me a number. It's just going to be an unlimited decimal, right? All righty. So next week, little shorter because it's July 4th holiday week. I'm technically off from my job this week. So I am taking some extra time with the family, but next week, let me know what you want me to go over. Let me know what you want to see. And I am happy to include it. I'm going to tag it over to Dr. A, but let me know what you want me to see, what you want to see from me in the upcoming weeks. And I look forward to seeing you then. I will see you next week. Have a safe and happy July 4th. Bye.
All right, so wasn't that an amazing session? Now, I know, depending on what exam you have to take, you're like, man, that was great, but she didn't address everything I needed. She focused on all different questions that I just need elementary, or I just need middle school, I just need high school. Don't worry. Since you're still with us, I've got a special surprise for you. If you use the coupon code, all capital letters, SINK35, that's SINK 35, that will take off 35% off any of our prep courses on our website at the Learning Liaisons. It doesn't have to just be math. It could be anything that you need that we offer. And this is going to be an ongoing deal for you guys who attend these live sessions, because these are great. I'm sure Amy opened your eyes to some new concepts, some new ways to tackle problems, building that confidence. But this is just a smidget of your exam, the concepts on your test. So if you want the comprehensive view with the practice with Amy, with the practice test, with the lessons and the content review, we've got your back on our video boot camps, which all of them feature Amy Sink, your math specialist. So if you want to take advantage of that, the code is SINK35. You can use that at checkout on the learningliaisons.com website. And all that information is on our website as well, and on the bottom of the screen in this video. So we are here to help you. Once again, always remember, it's when you pass, not if you pass. Thank you for joining us again today. And hopefully we'll see you next week too. Talk to you soon.